Every achievement of human engineering is a negotiation with three invisible forces: friction, gravity, and distance. When a cargo ship crashes through ocean waves or a jet pushes against the atmosphere, it fights the physical constraints defining our current limits. The global economy is a map of these negotiations. We spend trillions of dollars and fight wars over oil reserves, simply to acquire the energy density required to overcome these limits. But inside high-level physics labs, these constraints are being reclassified. Researchers are no longer viewing the vacuum of space as empty, but as a structured medium that can be engineered. In August 2025, researchers at the European XFEL used ultra-short X-ray pulses to capture the first direct visualization of molecular zero-point motion. Even at absolute zero, the atoms within an 11-atom molecule didn't sit still. They moved in a highly coordinated collective dance. By early 2026, the STAR collaboration demonstrated that the spins of real detectable matter are inherited from virtual particle pairs fluctuating in the vacuum. These experiments prove the nothingness of space is actually a reservoir of measurable information and energy. Once these measurements transition into applied engineering, the fundamental relationship between humanity and the physical world changes. We shift from a species that reacts to the environment to one that writes the rules for it. The first constraint to collapse is energy scarcity. Advances in fusion and the engineering of nanoscale vacuum cavities are moving us toward a period where electricity can be generated without the consumption of fuel. A refinery represents the massive, centralized infrastructure of a petroeconomy. In a world powered by vacuum interactions and fusion, these sprawling industrial complexes lose their primary economic function. Global logistics will see a similar disruption. When fuel costs disappear, the cost of moving goods across oceans drops to the price of maintaining the hull. The current energy-intensive model of global trade effectively dissolves. This enables the mass-scale desalination of water and provides the electricity needed for industrial automation in regions currently limited by high utility costs. It removes the primary economic barriers that currently isolate developing nations. When geography no longer determines a nation's access to energy, the 20th century geopolitical hierarchy, built on the control of resource pipelines, loses its leverage. Power becomes as decentralized as the energy itself. Once the energy problem is solved, the focus shifts to gravity and distance. We are moving from the era of rockets, which use combustion to fight inertia, to the era of space-time engineering. Subluminal warp physics involves manipulating the geometry of space. The craft remains stationary while compressing space in front of it and stretching it behind it. Inside this bubble, the crew is protected from lethal G-forces. It changes direction instantly because space moves around it. For civilians, this means the end of traditional geography. Travel between continents becomes a matter of minutes, and heavy infrastructure can be suspended without the need for roads or wings. The military implications are absolute. A craft that can execute a right-angle turn at several thousand miles per hour is impossible to intercept with current ballistic technology. Existing borders and radar networks become effectively transparent. The first nation to successfully engineer these metrics will hold a level of aerospace dominance that no traditional military can contest. History suggests that every major leap in energy and propulsion is weaponized by the military long before it reaches the public. Weaponizing metric engineering or massive energy densities creates a new category of threat. A craft capable of moving at relativistic speeds possesses the kinetic energy of a nuclear weapon, turning any propulsion breakthrough into a potential strike system. There is also the danger of global instability. If a single superpower hoards the control of post-scarcity energy, it could create an era of inequality that no previous economic system could match. These physics breakthroughs represent a great filter for our civilization. Our technological power is rapidly exceeding our social ability to manage it. Today, we live as an isolated species, competing for the limited resources available on a single planet. Our entire psychology is shaped by this scarcity. Mastering the vacuum and the fabric of spacetime removes those limits. It moves us into the deep cosmos, forcing a complete reconstruction of what it means to be human. We will have to confront questions we were never prepared for. What is the nature of reality if its very fabric can be reshaped? And once the stars are accessible, Are we truly ready to find out what else is out there? Governments fund this research because the successful mastery of the vacuum is the only way to ensure their survival in a spacefaring future. We are watching the transition from a planetary species to a cosmic one.